Hello everyone. Welcome to the second session of MySQL database training. So, till now we have covered up to popular storage engines. You can go through my previous video session where you will be getting the details on these 5 topics. So, in this session we will starting from MySQL server logs and we'll try covering till new features in MySQL 8. So without wasting time, let us just proceed with. So MySQL Server has several logs that can help you find out what activity is taking place. These are some of the logs which you can find in MySQL Server. By default, no logs are enabled except the error log on Windows. And by default, the server writes files for all enabled logs in the data dictionary. You can force the server to close and reopen the log files by flushing the logs. You can control the general query and slow query logs during runtime. You can enable or disable login or change the log file name. You can tell the server to write general query and slow query entries to log tables, log files, or both. So coming to error logs. The error log contains a record of MySQL startup and shutdown times. It also contains diagnostic messages such as errors, warnings, and notes that occur during server startup and shutdown and while the server is running. For example, if MySQL notices that a table needs to be automatically checked or repaired, it writes a message to the error log. If used to start MySQL safe, MySQL underscore safe may write messages to the error log. For example, when MySQL underscore safe notices abnormal MySQL exits, it restarts MySQL and writes a MySQL restarted message to the error log. Next comes the general query log. This general query log is a general record of what MySQL is doing. The server writes information to this log when client connects or disconnects, and it logs each SQL statement received from clients. The general query log can be very useful when you suspect an error in a client and want to know what the client exactly sent to MySQL. When the general query log is enabled, the server writes output to any destinations specified by the log output system variable, which is log underscore output. If you enable the server, if you enable the log, the server opens the log file and writes startup messages to it. However, further login of queries to the file does not occur until the file log destination is selected. If the destination is none, the server writes no queries even if the general log is enabled. You need to remember this. Setting the log file name has no effect on login if the log destination value does not contain file. Server restarts and log flushing do not cause any new general query log to be generated, although flushing closes and reopens it. Next comes binary log. Binary log is mainly it is used for replication. So the binary log contains events that describe database changes such as table creation operations or changes to table data. It also contains events for statements that potentially could have made changes unless row-based login is used. This binary log also contains information about how long each statement took that updated data. It has two important purposes. For replication, the binary log on a replication source server provides a record of the data changes to be sent to the replicas. The source sends the event contained in its binary log to its replicas. which then executes those events to make the same data changes that were made on the source. Next is certain data recovery operations require use of this binary log. After a backup has been restored, the events in the binary log that were recorded after the backup was made are re-executed. This is something you can compare with our archive logs or redo logs in Oracle. These events brings databases up to date from the point of the backup. This binary log is not used for statements such as select or show that do not modify data. To log all statements, we need to use the general query log. Running a server with binary logging enabled makes performance a bit slower. However, there are benefits of binary log in enabling you to set up replication and for restore operations. Generally, MySQL appends a numeric extension to the binary log base name to MySQL appends a numeric extension to the binary log base name to generate binary log file names. The number increases each time the server creates a new log file, thus creating an ordered series of files. The server creates a new file in the series each time when the server is restarted or started. Whenever the server flushes the log, then the size of the current file reaches the max bin log size. A binary log file may become larger than the max bin log size if we are using large transactions, because the transaction is written to the file in one piece and never split between files. If you are using replication, you should not delete old binary log files on the source until you are sure that no replica still needs to use them. Like similar way, we go ahead with our archive logs. Archive logs are sent to the standby files, and after those are sent and applied, then only we can delete them from the primary, right? It is the same way we are doing for binary logs. So if the server is unable to write to the binary log, flush binary log files, or synchronize the binary log to disk, the binary log on the source can become inconsistent and replicas can lose synchronization with the source. Next comes the relay log. This relay log is used only on replicas to hold data changes from the replication source that must also be made on the replica. So data changes received from replication source server, that is relay log. Next comes the slow query log. In this log, the queries that took more than the long query time parameters specified in seconds to execute, those queries will be written in here. And in DDL log, the metadata operations performed by DDL statements, those are written in here. Next comes the MySQL socket file. So a socket file, what is it? A socket file does not actually contain any data. It transports it. It is a special type of file created with special system calls or commands, and it is not an ordinary file. It is like a pipe the server and the clients can use to connect and exchange requests and data, and it is only used locally. And when you specify host equals to localhost while entering to the database, I will be going ahead with the commands of how to enter to the database, how to log into the database. At that time we will see this, but means you just need to remember, whenever you specify host equals to localhost, MySQL client will try to log into this MySQL server using Unix name pipe which requires a socket file, and it is in the format .sock. So this can be bypassed, means this host equals to localhost can be bypassed by specifying host equals to 127.0.0.1, which is nothing but the local host only, and This will make MySQL client use TCP to connect to the server. Socket files connections are secure by default. So next comes client server connection ports. As you see in this table, the default ports are mentioned in here. You can obviously change these ports. So port 3306 is the default port for the classic MySQL protocol, which is used by the MySQL client, MySQL connectors, and utilities such as MySQL dump and MySQL pump. The port for X protocol, which is MySQL X underscore port, supported by clients such as MySQL shell, MySQL connectors, and MySQL router, is calculated by multiplying the port used by your MySQL protocol, MySQL by 10. So you can see this one is 3306. That's why the MySQL X protocol is multiplied by 10 with the classic MySQL protocol. So it comes 33060. As of MySQL 8.0.14, the server permits a TCP IP port to be configured specifically for administrative connections. This is the one. This provides an alternative to the single administrative connection that is permitted on the network interfaces used for ordinary connections, and the default port of this being 33062. Next comes the data dictionary. So data dictionary is the information managed by the MySQL server, which is stored under a directory. This data directory subdirectories. So what is it? Each subdirectory of the data directory is a database directory and corresponds to a database managed by the server. All MySQL installations have certain standard databases. The MySQL directory corresponds to the MySQL system schema, which contains information required by the MySQL server as it runs. This database contains data dictionary, tables, and system tables. This is a system schema. We will be covering our each schema in our next topics. So till then, let us proceed as we go through the slide. The performance schema directory corresponds to the performance schema, which provides information used to inspect the internal execution of the server at runtime. Then the sixth directory corresponds to the sys schema, which provides a set of objects to help interpret performance schema information more easily. The NDB info directory, this corresponds to the NDB info database that stores information specific to the NDB cluster. And this is present only for installation built to include NDB cluster. Other subdirectories correspond to databases created by users or applications, such as log files written by the server, InnoDB Tablespace and log files, the server process ID file while the server is running, the MySQL-auto.cnf, which is nothing but the parameter file of your MySQL instance that stores the persistent global system variable settings, which I said. So MySQL uses var lib MySQL directory /var/lib/MySQL directory as the default directory for default data directory for Linux based systems. To identify the current data, we need to use the command select @data directory. We will be seeing all of these things during a practical session. Next comes the InnoDB system tablespace. The system tablespace is the storage area for the InnoDB data dictionary, the double write buffer, the change buffer, and the undo logs. So what is change buffer? This change buffer is a special data structure that caches changes to the secondary index pages when those pages are not in the buffer pool. The buffer changes which may result from insert, update or delete operations are merged later when the pages are loaded into the buffer pool by other read operations. What is double write buffer? This double write buffer is a storage area where InnoDB writes pages flushed from the buffer pool before writing the pages to their proper positions in the InnoDB data files. If there is an operating system or storage subsystem or unexpected MySQL process exit in the middle of a page write, InnoDB can find a good copy of the page from this double write buffer during crash recovery. Although data is written twice, this double write buffer does not require twice as much I/O overhead or twice as many I/O operations. Data is written to this double write buffer in a large sequential chunk with a single fsync call to the operating system. The double write buffer is enabled by default in most of the cases. To disable this double write buffer, you can use the command set InnoDB underscore double write to 0. Like this, you can do it. This system tablespace can have one or so. Coming back to this system tablespace, it can have one or more data files. By default, a single system tablespace data file named IBData1 is created in the data dictionary. The size and number of system data tablespace data files is defined by the parameter InnoDB underscore data underscore file underscore path startup option. And the easiest way to increase the size of this system tablespace is to configure it to be auto extending. So in this example, what you see here, InnoDB underscore data underscore path file path IBData1 is 10 MB, which is then auto extended by default. So, and if you want to add means if your system tablespace data file is getting bigger, so what you can do in that case, you can go ahead. In this example, IBData1, this data file has been restricted to 80 MB, after which this IBData2 will be auto extended from 50 MB. So this is what it is mentioned in here. Next comes our files per table spaces. So a file per tablespace contains data and indexes for a single InnoDB table and is stored on the file system in a single data file. So some of the advantages of this is that disk space is returned to the operating system after truncating or dropping a table created in a file per tablespace. Truncating or dropping a table stored in the system tablespace creates free space within the system tablespace, which can only be used for InnoDB. In other words, this system tablespace does not shrink in size after a table is truncated or dropped. A table copying altered table operation on a table that resides in the system tablespace can increase the amount of disk space occupied by the tablespace. So such operations may require as much additional space as the data in the table plus indexes. This space is not released back to the operating system as it is for file per tablespace. Then truncate table performance is better when executed on tables that reside in files per tablespace. These tables created in files per tablespace use the Barracuda file format. The Barracuda file format enables features associated with dynamic and compressed row formats. So those are dynamic. These tables stored in individual tablespace data files can save time and improve chances for a successful recovery when data corruption occurs, when backups or binary logs are unavailable, or when the MySQL server instance cannot be restarted. Next comes the undo tablespaces. So undo tablespaces contains the undo logs, which are collections of records containing information about how to undo the latest change by a transaction to a clustered index record. So this is similar to Oracle undo tablespaces. Undo logs are stored in the system tablespace by default but can be stored in one or more undo tablespaces. Using undo tablespaces can reduce the amount of space required for undo logs in any one tablespace. The IO patterns for undo logs also make undo tablespace good candidates for SSD storage. The number of undo tablespaces used by InnoDB is controlled by the InnoDB undo tablespace option. This option can only be configured when initializing the MySQL instance. It cannot be changed afterwards. So till now we are done with. In this session we have seen MySQL server logs, MySQL socket file and InnoDB tablespaces. In our next session we will be seeing MySQL database schemas and new features which are included in from MySQL 8. So this concludes our second session of MySQL training. So we'll stay tuned and please do like, share, subscribe and also comment. We'll be meeting in the next session with these topics. Probably we'll be covering this in one session, MySQL database schemas and the new features in MySQL 8. And these practical sessions will be covered in each session separately. So thanks a lot for watching this video. Please do like, share, subscribe. Take care of yourself. Thank you.